Let's look at a new strategy for solving a system of equations. We're going to look at it when we have one solution, all solutions, infinite, and no solutions. So here we know we have a one solution, meaning we already know it intersects. I'm just using this as a visual so we can see it. To eliminate means we're going to solve really by eliminating one of the either x or y's. We're going to create that zero pair. So what does this look like? All right, I'm going to use our two equations. I'm going to write my second equation. I want to give it a little bit more room. And imagine I'm adding these two together. Now, if I were to add them as is, I would just end up with 2y is equal to negative x plus 6. But our goal is to somehow eliminate one of these equations. And when we eliminate them, we can solve for the other. So if there was a way to eliminate this x, I could solve for y. That's going to be our goal. So looking at these two numbers, is there any way that I can create a zero pair the way they are? No. So I'm going to use multiplication to create a new equation that is still equivalent that will have a zero pair. So looking here, looking right here and right here, what if there was a 2 in front of this x? If there was a positive 2, I could eliminate these. So that's one option. So I'm going to do just that. I'm going to multiply this entire equation by 2. Now I'm going to have this. Let me write my first equation just so that it's still in front. So my second equation is now 2y is equal to 2x plus 6. Now when you add them up, I'm going to get 3y is equal to, these are eliminated, it's happened, it's equal to 9. I can solve for y now. Now that I've eliminated the x, I can solve for y. And y is equal to 3. And just by, I do have the graph here, was one we used earlier. You can see that my y coordinate is 3 for the solution. You're not always going to have the graph though. I just want to show that is true. So now I'm going to take that 3 and I'm going to substitute. Okay, so let's go into the very first equation. Y equals x plus 3. 3 is equal to x plus 3. And now I can solve for x. 0 is equal to x. So now I know my x coordinate is 0. And so my solution is 0, 3. How do I know it's not 3, 0? Because my x is equal to 3 and my x is equal to 0, and my y is equal to 3. So here's my solution. And just to verify, I'm going to do the other equation as well. Y is equal to negative 2x plus 3. 3 is equal to negative 2x plus 3. I want to move that 3 over. Zero is equal to negative 2x. I can divide by negative 2, divide by negative 2. X is equal to 0. So I still get the exact same solution. Hit pause and jot this down into your notes. Now we're going to look at a second one. As you can see here, our work of elimination does have a point at 0, 3. But what's going to happen when we have no solution? So we could already see our two lines are not intersecting. So what if we tried elimination in this case? Y is equal to 3x. Y is equal to 3x minus 2. Okay. I want to add them. I still want to create a zero pair. I'm going to put a plus 0 here just to have it balanced. And just looking at it, I need to turn one of the equations negative. So I'm just going to multiply just the top one. I'm going to multiply it by -1. Okay, so here's my new equation now. And pretend I'm distributing. -y is equal to -3x plus 0. Y is equal to 3x plus 2. So what happens when I add these two equations? Well, turns out I eliminate the y's and the x's, and I just end up with a 2. So here's the problem. There is no solution here. Absolutely none. 0 is equal to, in this case, 0 plus 2, or 0 is equal to 2. That is not true. This is not a solution. So this tells me there are no solutions. And again, this is a case where, let's say you were solving with elimination and you didn't do a check first. Now, to be fair, we know that they both have the same slope. We can see it. They both have a slope of 3, m equals 3. And we know that the b's are different, where one b equals 0 and b equals -2. So I already know just from looking at the equation that these are going to be parallel lines. But I just wanted to also show you what happens when you try to solve this equation with elimination. As you can see, I have no solution. This is not a valid equation. Hit pause and jot this down in your notes. And let's try one more. What happens when you have infinite solutions? So same thing. Y plus 2 is equal to 2x. And here's my blue. Y is equal to 2x minus 1. I do need them in the same form, so I'm going to distribute here and here, and I get y is equal to 2x minus 2. Okay, one is in y-intercept form, one is not, so let's put them both into y-intercept form just to make it easier. Y plus 2 equals 2x. Let's subtract 2 on both sides. Y is equal to 2x minus 2. All right, what do you see, math marbles? What are you noticing about these two equations? They're exactly the same. They're absolutely exactly the same. So I can just multiply, I'm just going to multiply one of them by -1. Because I see this. And so I already know that's my big hint that they're the same line, that there's going to be infinite solutions. But let's say you don't see that, you don't recognize it, it's just not happening in your head. All right, let's say we multiply this one by -1. Okay? Now what do I have as my equations? Now I have y is equal, -y is equal to -2x plus 2. And I have y is equal to 2x minus 2. And when you add all of these up, what are you going to get? 0 is equal to 0 plus 0. So I end up with 0 equals 0, which is just like a reflection of itself. So this is my clue that this is infinite. Okay, so if you end up with a solution like 1 equals 1 or 0 equals 0 or 8 equals 8, then you just know that you have infinite solutions. But there are tons of clues here beforehand. One is by recognizing if they have the same slope and the same intercept, then you know they are the same line. So that should be your first hint that you're going to have infinite solutions that are exactly the same line. And that's what we're seeing here. So hit pause and jot this down. And now you know what happens with elimination. What happens when you algebraically try to eliminate one of the terms. If you have a term like this, 0 equals 0, you know it is infinite. If you have a solution that does not make any sense, like 0 equals 2, that does not make sense, is not valid, then you have no solutions. You have two parallel lines. And if you're able to actually solve for one variable and then get the second, then you have one point of intersection.